I'm pleased and honored to be here with you to share a few tips on bucket elevator maintenance. As I said, I'm honored and thank you for the opportunity that you give me, you give TAPCO. We will learn a few things today. I really want to focus on a few tips that you use for your cups, for your elevator buckets, that will help you increase productivity, will maintain the life of your bucket longer, and most importantly, save you money on your investment on your elevator. First, I'd like to start with the beginning of how this process changed from metallic buckets to plastic. The change was made around in the mid-70s. The main advantage of these buckets is that first is non-sparking, which gives a great safety feature. When you have a metallic bucket that produces spark, you're very prone to have an explosion in your elevator. When you have an explosion, they're very, very strong, damaging the entire material, the entire equipment, and you lose your entire investment. Plastic buckets have the advantage of lasting longer. They are lighter, they save energy, they do not contaminate the product that they're carrying. Most of them are food grade, which is a great advantage for feed meals and other food applications that will be eventually be consumed by humans. There are a few elevator bucket styles. The CC style, which is the style that you guys are more familiar with, is for agricultural applications. This bucket, it has the CC design, the cake wheel is designed, which was invented in the 1930s. This gives you the advantage of discharging with the centrifugal discharge, meaning it's projected, it's not dumped to the silo, it pretty much throws it away. There's not any remainings in your bucket. It allows for a faster discharge. The AA style bucket, which I will not get more into, is more for industrial applications. As we can see here, the differences focuses on the design on the bottom of the bucket, also focuses on the speed that the elevator is going at. We will see later the various speeds that this bucket should be placed at. Here is what I was talking about. If you can see in the bottom of the CC bucket, you see different breaks, different linear levels that allow a clean discharge for the bucket. This will allow for all of the material to be discharged, while you have other geometries that will not do this very smoothly. In order to determine the type of bucket that we'll be using for your elevator, we need to first see what type of product you're conveying. We need to see different variables, such as the size, how dense it is, the temperature, if it's sticky, if it's not sticky, if it has any moisture, or if there's any abrasion. We will see later on that depending on the type of product that you are conveying, we will recommend different types of plastics. There are a number of plastics that can be recommended for your application. In order to first better get to know the bucket that you will put in your conveyor, it's important to know how to measure. Some people tell me, well, we have a bucket that is 17 by 5, and then you realize that those dimensions don't exist. So first we're going to look at the geometry of the bucket. If you can see the measurement A, that's what we call the length. Measurement B, that's what we call the projection. And that's really the first step into getting to know the bucket and getting the right bucket for your elevator. If you tell me I want a 9 by 5, that means I have a bucket with 9-inch length with a 5-inch projection. So A and B meaning length and projection. Also, in order to determine the capacity of the bucket, we use depth and water level. For bucket purposes, we like to tell our customers that the true capacity of your bucket is water level plus 10%. This is the maximum potential of your bucket, and this is what we want to achieve when carrying material. When designing the casing of the belt, people tell us how wide should my belt be, how tall should be the pitch between the buckets. And it's really a very, very simple formula that we have come up with and we have used for up to 20 years or even more. It's a very easy formula. Let's just pretend that you have a 9 by 6 bucket, meaning 9 length bucket by 6-inch projection. We simply recommend that you add 1 inch to the width of the bucket. So if you have 9-inch wide bucket, you will have a 10-inch wide belt. That means that will allow you to leave 1 inch on on the side and each side of the bucket. Also, when designing the casing, the trunking, we depending on the bucket length, if you have a bucket that goes up to 8 inches in length, we recommend 3 inches between the projection, the final point of the bucket and the border of the elevator. About 7.6 centimeters. This is the next important measurement to take into consideration when putting together the spacing between one bucket and the next. But traditionally, we say for the projection of your bucket, going back again to the 9x6 bucket, it's very simple. You just add 2 inches, meaning when you have the holes of the bucket and you make the punching in the belt, you count the distance of the projection of the bucket, which is in this case 9x6, will be 6 inches, and then you just add 2 inches. So you have an 8-inch pitch distance between one bucket and the other one. This is what we recommend at TAPCO for optimal bucket elevator capacity. A lot of people like to use just projection plus 1. It's okay. I mean, it's not going to hurt you much. We at TAPCO recommend 2. But if you prefer to do 1 inch, that's fine. You may be able to fit a couple more buckets in your belt. When you want to put a low profile bucket is basically a normal shaped bucket, and at our facility we do a special cut of the ears, which means you can place them very close together. You can almost put them one on top of each other. This means that you can place more buckets in your elevator, but doesn't necessarily mean that you will be carrying more. A lot of people like to use this, a lot of people doesn't. It's really up to the choice of the customer. We certainly recommend just 1 inch minus the projection, meaning, let's go back to our 9x6 bucket that we were talking about earlier. You have a 9x6 bucket and you cut it for a low profile, meaning you cut the upper ears. You will only place it 6 inches minus 1, so it would be 5 inch. Here's the formula: low profile, 1 inch less than nominal projection. As I said, for optimal uses capacity, I recommend projection plus 2 with a normal shape. Moving on to which plastics are better to use. At TAPCO, over the years that we have been in the industry, we have realized that there are 3 main plastics that can be used for agricultural applications. These are polyethylene, nylon, and urethane. The main and most popular throughout the world is polyethylene. Polyethylene brings many advantages. It's a very economical plastic, very durable, it's flexible, tough, and it's very lightweight. And a lot of people prefer this plastic because it comes with the United States FDA standards, meaning you can convey any type of food or elements that will be consumed by humans. The next plastic that is popular is urethane. Now, urethane it's an engineered plastic that one must be careful when choosing your bucket to have urethane. It's a very good plastic. It's very good for sticky applications. A lot of our clients use it for patty rice. When you have an elevator that you're running constantly and the material that you're conveying, it's sticking to the bottom of the bucket, meaning when it's time to discharge, maybe up to 10 to 20% of it stays in the bottom of the bucket. You're losing capacity on your bucket, and eventually it will create weight on the bucket, damaging the capacity, damaging the integrity of the bucket. So when you have sticky applications, urethane is very good because the surface of it's designed to let go of any material that got stuck in there. As I said, patty rice, a lot of sugary applications, a lot of sands in mining applications use this when it sticks. It is also very good for abrasion. It is an extremely flexible material, which one can, if you grab a urethane bucket, you can bend it, and it's extremely malleable. And when you let the force go, it will come back to its shape. We have a number of clients that use this for extreme abrasiveness, such as shells and glass. When you have very sharp objects that otherwise would damage your polyethylene buckets, this is a great choice. The only downside with urethane that we have found over the years is that you must be careful. If your application has moisture in it, if your application has a high content of water or moisture, over the time the water will make a chemical reaction and break the bucket. It will have a adverse reaction to the bucket, and it will dramatically shape the integrity, change the integrity of the bucket. So you must be careful. If you think your product is very abrasive, but you are carrying a high volume of moisture or water, we have other options. We tend to say if you have water, just don't use the urethane. we will recommend you another. But if your application is very sticky and very sharp, this is definitely the best material. We have had great success with urethane here in Thailand. Just at the end of last year, we shipped a number of buckets for rice applications because of the stickiness. The customer found that after 2 years of trying samples of urethane, these buckets were intact as compared to the regular polyethylene buckets. It took 2 years for them to realize that urethane is definitely their choice. And you will realize over time that yes, it will cost you a little bit more, but it will last you 5-6 times longer than your regular poly. You will save on downtime while using this type of plastic. Then we'll move into nylon. This is our other engineering plastic. This is very comparable to the urethane. It's extremely good for abrasive products, just like urethane is. This is what we call our toughest product. This is the product that is not going to break. As I was saying, with your poly bucket, if you give it a good maintenance, depending on the usage that you will give it, it will last 2 to 3 years. Your nylon bucket will last 5, 6, maybe 7 years. Just the other day, I have a client in Mexico that uses poly buckets. They have a rail port just outside of Mexico City, the biggest rail port in the country, and they are very pleased with our poly buckets. But after a year, they use big buckets. We sent some samples about 3 years ago of our nylon buckets to see for their usage. So while they were replacing every 6 months to 1 year their poly buckets, they realized that it had been 4 years since they tried their sample nylon bucket. They realized, just like in the urethane buckets I was saying earlier, that the investment at the upfront will be a little bit more, but over time they save in downtime, and obviously that will get their production going. So just to conclude with the nylon, it has outstanding impact resistance, very good for abrasion. It's very good with all kinds of materials. When you have a doubt on whether to use polyurethane or nylon, we usually tell the client, if they don't have a lot of information, nylon is our toughest product and is the best bucket out there as far as plastics go. Currently, we are initiating a production of our FDA-approved nylon. Current nylon buckets do not meet the requirements of the FDA. However, we have just introduced a new line for FDA-approved buckets. Another great advantage of nylon is that they are highly resistant to high temperatures. The most common issues that our clients go through when having problems with their buckets. Sometimes people blame the bucket, people blame the belt, people blame the casing, people blame the manager, or people blame the product that is being conveyed. But maintaining your bucket elevator is just like maintaining your car. You have to give it regular checks and it will last you longer. These are very, very simple things that you can do in order to improve the usage of your buckets and to avoid downtime, as I said before. Here are the most common problems. I already went over some of them. Product sticking in the bucket, as I said, the best way to resolve this, if you don't have any moisture, switch to urethane bucket is your best option. Loose bolts, it's very good to have a regular checkup of your bolts to tighten them up. It is very important to check that you're using grade 2 bolts. A lot of people say we do a lot of checkup on our bolts, we make sure they're tight, we make sure they're well put together. But then we realize that the resistance of the bolt, the thread of the bolt, is not up to the challenge of an elevator bucket. So it is important to make sure that these bolts meet the grade 2 standard. These bolts are very resistant, and it doesn't matter how much force you put into them. They will bend if you want, but they will never break. Here's the first tip that we will talk about for saving energy first in your bucket, saving energy in your elevator, and improving the capacity. It may sound strange that it is good to put holes in the bottom, but believe it or not, this will actually increase the capacity. Very simple physics to explain this phenomenon. What happens is when the bucket is coming down and scooping, there is a cushion of air on the bottom. When there's a cushion of air, you don't reach the entire capacity of the bucket. Therefore, there's a cushion of air, then your product, then the other bucket. So in order to avoid that cushion of air, you need to let air breathe. It's good to put some holes in there. Sounds strange, but it works. It works really good. In fact, if your product is falling through the holes, it's very easy to fall. It will just fall in the next bucket, and in the next bucket, and in the next bucket, and you will lose more by not putting this hole. For dense materials, especially for very loose, very dense materials, dust-like materials, this is a great advantage. So this is the advantage when the cup is going up. The advantage when the cup is going down is that it's not like a parachute. It's not catching air. The air is flowing freely through the holes. Therefore, it uses a lot less energy and makes the rotation smoother. So these are the two main reasons for using venting in your bucket. We do several types depending on your application. If you have more dense material, we usually recommend vent 4, venting pattern 4, or venting pattern 3. I know especially here in Southeast Asia, it's very, very common for our clients to specify vent 4. They have realized over the years that venting their buckets will really improve the efficiency of their elevator.